Answering subscriber questions, we're still looking at M.2 NVMe heatsinks, and we've got a question we're still working on with one of our subscribers. And this is the second part of IMT 558 Deluxe question about M.2 NVMe heatsinks. Do you need one? We looked at the Thermal Grizzly in the last video. Kind of disappointed in that. And this time we're going to look at the EKWB as he requested. So the title of this video will be the EKWB EK-M.2 NVMe Heatsink. And we'll do the four things that we do. We'll do an unboxing, an inspection, an installation, and a test. And we've updated the results that we've been showing because this is heatsink number 10. And by the way, Pablo has asked for 2 more heatsinks that we're going to be looking at. One that I had already said we weren't going to do, but because he's been the second request, we are going to do. Which of the 3 places we put a heatsink, it's only going to work on one, but we'll get into that later. Right now, let's take a look at what we have in common with this heatsink versus the second heatsink we looked at a few minutes ago. We've still got those brackets. Now, of the major components, we have an undercarriage, we have brackets, we have a heatsink, and we have thermal pads. And yes, we have 2 thermal pads, one below 0.5 millimeter and one above a 1 millimeter. And some of you had asked about why we did what we did with the others. Okay, remember, when we started this whole thing with heat sinks, we had 6, then 8 we were going to look at. That list has grown now to 10. It's now grown to 12. So the parameters we were working with when we started was what all is involved, how can we keep it simple, so we keep it all the same. Some of the questions that have been asked are relevant and valid. However, we're not going to go back and retest. So some thermal pads were only meant to be on top. Some coolers were meant to have 2 thermal pads. So going forward, because we have 2 thermal pads, we're going to use 2 thermal pads, but I'm not going to go back and retest. I still, however, want to test the top 3 based on parameters for the 3 locations. Primary would be a dual M.2 NVMe adapter. Secondary, of course, will be a quad card that doesn't have a cooler on it. We'll go through the system and outline all that. And then the third place, or tertiary, would be on the motherboard. Now, some of these situations for a motherboard, and I bring this up now, this has the possibility that this could be used on a motherboard where you still have clearance for the cards. Now, it was appropriate for us to measure the clearance on the copper heatsink because it was just a copper and a thermal pad in a laptop. Because knowing what that thickness is, what we don't know is what the height above it is. And that will be in another video. However, for this, it's appropriate because as we look at the clips that go up over it, it's a predefined compression where we're not getting the compression where we have the elongated screw holes where we can set it and compress it. This is just clip on and that's it. Let me show you. That brings up another point. Okay, the materials used: an aluminum front cover, anodized aluminum, an aluminum back plate, and a stainless steel clip. So those 3 main components. Number 4 being the thermal pads, of which there are 2. I've already outlined that. Shows the thickness, made in Slovenia, and this is designed, as it says here, for a connector for a 4.2 millimeter height, as seen for examples. This is made specifically for single-sided memory, not double-sided. And I think that clarification for distinction is important because some of the heat sinks we looked at can be used for dual-sided. The memory we happen to be using is single-sided. I'll go through all that when we get to it. And the chart that I want to show you guys, once we get through the first 3 steps before we do the 4th step with the test, I'm going to bring that up, show you the results, because some of the numbers that I've talked about that I didn't have, for example, what is the reference for the heatsink on the motherboard, that's now in the chart. So the numbering of 10 versus the numbering on that chart is different. So that's why I want to mention that now. So when you see it, you won't blow your mind. And I'll also show you and tell you how we can do a screen capture so you can have that on your hard drive. So that way as you, and by the way, this is Builder By. My name's Gil Boyd. Welcome. Thanks for joining us. Let's go overhead. We'll start with a good old unboxing. It's interesting, this came from Titan Rig on Amazon. I mention that because they were the only ones that had it. Nice little box. Looks like we have a serial number on it. I'm always curious about packaging. I like to know what we get in a box, and I think it's important to pay attention to all those details. So this is the EK-M.2 NVMe Heatsink, and it comes in different colors. We have the black anodized aluminum. A pretty simple box. It looked like it was a push-through design. It's not. It has a lid on the box. So from this point, we'll roll that over, and we should be able to just pull that up and out. Yep, little foam wrapper on it. Nice. Our brackets, as stated, are stainless steel. 2 in there. We have the 2 main components. which is the mounting bracket, the bottom plate, and the heatsink on top. And we have our thermal pads, of which these are long. The bottom thermal pad, 0.5 millimeter, the top thermal pad, 1 millimeter. I'm going to be curious to see what kind of compression we get with these. So I'll set those aside. I want to keep the camera as tight as I can. We also have an instruction sheet. Point this out. Let's take a look at that. We have the heatsink top, the notch we'll need to pay attention to so that all lines up. The memory, thermal pad, top and bottom plate, then the clips. Nothing on the back side. So we'll get these out of the packages. I'm going to do my thing. We work with a lot of components. I've gone over the issues with ESD before, so I'm not going to be repeating that. For those that don't, that's your choice. It is our choice to do so. I'll use a micro screwdriver to help me get into the packages. 2 clips, top plate. We've got a foil sticker to remove. The bottom plate looks to be generic. In other words, it's cut. We have a notch on one end, so we're going to line those up. But there doesn't appear to be a top or a bottom to it. Both sides appear to be machined for the same. Nice machining, clean. So using a micro screwdriver, we'll peel that foil off the sticker. Voila. And if I didn't know better, it looks like that has another sticker on top of it. And it does. Interesting. So there's 2 stickers there. So I'm using my fingernail so I don't scratch that to pull that second layer off. That looks more like it. Okay. Double layer. Interesting. All that just for a protective cover that we'll never see. Okay. And the pads are going to need to be cut to length. That's kind of curious. So we'll get the card out. Now I have left the thermal grizzly on because I want you to see how those clips are mounted and make note of that. The thermal grizzly clips extend past the memory or past the heatsink, whereas the clips that are going to go on the EK water block do not. That's the point of that. Of the heat sinks that we have looked at and are looking at, these are the only 2 that have these clips like this. And the clips on this one are built on, whereas these clips are separate. I think these separate clips are a smarter idea. That's just my opinion. And you can see the difference in the height and how those clips stand up. You can get a sense of that. So we'll see how that works. I just wanted to point that out. And what I just found out, these thermal grizzly clips are really easy to bend because they're built on. I'm not wild about that. Thermal grizzly may have designed great thermal pads, but I'm a little concerned about the way they designed their cooler, especially after taking that apart. I'm not too fond of that. You can get an example here of these brackets because that's built in, that's too easy to bend. Can't do anything about increasing tension, but they're easy to bend this way, and they don't have memory to stretch. That's just the metal of whatever this metal is. And I don't think that's stainless steel, but I have to go back and check. But anyway, what I want to show is those clips. It's more prevalent now with the drive out of there. So we'll see how it compares. But I'm going to set that aside and we'll look. I'm also curious because this has the potential with the EKWB of being on the motherboard. So I'm curious, and I think what I want to do is we'll do our 2 tests. One, we'll test it on the, let's take a look at the card. The Supermicro dual M.2 NVMe adapter, and we're going to be testing that with the WD Black SN850 as the primary drive. And of course the secondary on this that we're not testing is the Samsung 980 Pro. Both of these are PCI Express 4.0 second generation. And I'll get into the specs of the machine, what we're testing with, and how this is all set up when we get to that point. But I think it's relevant because it looks like the height of these, and I say this now because somebody asked about, what's the thickness of this whole thing when it's all stacked up. Well, for the copper in a laptop, that's relevant. However, to measure the thickness of this, the only thing that's relevant is the height clearance over the motherboard. In other words, if this heatsink can be used and replaced, and what we're saying is, and if the results are better than what's on the motherboard, and the only difference I can see is we have 2 thermal pads versus 1 with the stock heatsink, what's the height clearance? In other words, will this work with a card above it? And so that's what I'm curious about doing the second test, where I can lay a straight edge down, see if there's any rocking, to see if it'll clear. And I'm saying that based on because of the way the clips are designed. That's a possibility. So I'm thinking about we need to do that. So the first thing is we'll get this on here and get it on the Supermicro card, see what kind of results we get. Then we'll put it on the motherboard, see what kind of results we get. and look at our chart. We need to look at the chart a couple of times. One before the test and again after. It'll be self-explanatory. Just give me patience. For now, I'll set that aside because we need to look at how this is all going to go together. And I want to dry fit before I assemble anything to see what I'm looking at. So the blue I'll put next to the metal. And this is a thin pad that'll be on the bottom, thick pad on top. So we're going to do this. I can eyeball what I have to work with. And I'm curious about the memory, how that's going to work based on the notch. And again, we'll base our alignment on the notch. So that'll be at 0. Those will line up perfect. And based on the notch on the back side, which is the notch on the card on the bottom right, it looks like we're exactly the same length. So that's what I wanted to find out. So pad is long enough to cover everything. So we'll cover from controller here on the right side all the way through on the memory on the left side. And I hope we get enough compression so we can pull that down. I didn't like the compression on the Thermal Grizzly. I got to tell you that. I'm concerned about the compression on this, but I'm also concerned about being able to take it off. But the way the clip is designed, let's take a look at that. This is really smart, and I didn't notice this until just now looking at it. That clip has a hook on one side, and on the other side, it's got this area here where you can bring it up into it. Now, the problem's going to be taking it off, pushing from here, but putting it on right from here. That reminds me, some of the brackets we had on the CPU coolers goes back, I don't know, maybe 10 years or whatever, where you had to have a regular screwdriver and push that on there to get the cooler on the CPU. This kind of reminds me of that. We'll see. My concern is going to be getting it off, but it'll come off from one side. That's my point. As always, the details matter. So to measure up, we need to cut our thermal pads to length and make sure we are good to go. I can do that. And what I will do, something that I can use as a hard surface, I'm using the back of a notepad because sometimes I like to refer to these temperatures on what we're doing. And I will take the knife and just make a cut. That gets me my length. If you got an X-Acto knife, that would probably be working as well. I'm working with what I've got. I could probably use a pair of scissors for this as well. This one, I'll line it up here, and make my cut. And I want to cut deep enough that I get all the way through, and I did. Okay, wow. That's quite a bit of thermal pad I have left over. Not enough, but almost. You can see there the two pieces I cut, how much is left over. Got to keep a finger on there to keep them down because they were bent. But that's how much I had left over on thermal pad. Kind of surprised. Anyway, so much for that. So we'll set those aside. I mentioned it. I know it's just a thermal pad, but I don't like to waste stuff. I'm just saying. We have a thick pad and a thin pad. So the bottom pad is going to be the thin pad, 0.5. So again, using the micro screwdriver, I'll grab one corner. When we start testing thermal pads, we're going to have to do some cutting, length and width. And the W over MK value, of course, is not given on these thermal pads either. So we are testing with stock to see what kind of results we get. There we go. Okay. And I will roll that just a little bit. Press that down. Center. Thermal pads are one-time use. I like to save the covers because I got to be able to pull this off to go to the next one. All right. Again, dry fit. That'll cover fine. So this pad is down. That's the thin one. We'll pull the protective cover off of that. I don't know what this thermal pad's made of, but it is much more delicate than any I have messed with. I'm very gingerly peeling that off. Got a little bit of a stretch in it. A little bit long. That's going to be... I'm going to use a pair of scissors. Do just a little bit of a trim based on what I'm seeing. Perfect. Do a dry fit. Yeah, I just want to cover the memory. That's a much better fit. So I cut not quite 1/8 of an inch off the length. I just need to cover, set that aside so you can see it. I just need to cover the memory and the controller, nothing more. Okay, I will peel off the clear side. the plastic film they use on their thermal pads is thicker. So it's a little bit, you got to work it. I'm going to start on the back end of this one because I don't want that getting down in there too far. Okay, straight in line. Again, the notch. Now for the top. The Thermal Grizzly I think was the easiest to assemble, and this one seems to be the most tedious to assemble. Okay, we've got our stack. Now for the clips. Need to gingerly pick this up, and yes, I still got to peel the tape off. I want to look at this first. And these clips have to hook on and clip over. Okay, this is going to be a tricky sandwich to do. Need to peel the pad, backing. Now this thin plastic apparently must be the top side because it's thinner and it comes off a whole lot easier than the clear plastic. Okay, because this is difficult to grab, I'm going to keep it up in the air. Little hole right there where the button is, where the glue is that holds the label. So I'm going to keep this up in the air and put these two together and see how this all lines up. Lined up on the left end for the notch. Still holding this in my hands. And I'm good here on the back side. Lined up for this notch. I want to make sure I clear it right here. Now we'll put the heatsink on top. Let's take a look at our sandwich. We're good on the left with the notch. That'll clear fine. And we're good here on the right where we will clear the edge of the card by about a 1/64 of an inch. Now we got to go for these clips. Let's see how well this is going to work. This looks tricky. We're going to grab in that groove right there. But we have grooves here on the back for positioning right there where those clips have to sit. So I'm going to position that in that area and bring that over. And I'm going to apply pressure to that and push right on up to get that to clip in. And we have to be spot on with these notches. So if you can see here, I'm centered on that groove right here. And I want to come straight up as I'm applying pressure and pushing. I don't like the amount of pressure I'm having to use to get that to fit. I'm going to try using some bent needle nose pliers to help me to pull that up. I got to tell you, I think that's dangerous because I could see where someone could either tear something up or hurt themselves. I've got one clip on one side, but I don't quite have the clip on the other side. Okay, I used bent needle nose pliers to pull that up, and that does have some tension to it, but I don't like the amount of pressure required to do that. I use these bent needle nose pliers to help me to pull that up. You can see how that fits. And I am in the groove on the back side. That's crucial, that alignment across there. And those are tight. So now I'm going to go for the second one, same way. And if you can look kind of how that fits, because that clears across the top, that has the potential for being used on the motherboard. But man, I sure had to pull that down tight. So I'll reverse the procedure and do the same thing on the other end. I don't think this is something for just anybody to do. You may want to get someone to do this for you or help you with it because these little clamps are really tight. I prefer something that I can get hold of gently. This requires a lot of brute force. Okay, here we go again. Definitely have to have the bent needle nose pliers to pull that up. I've got a pretty good grip, but that took quite a bit to get that on. Now the camera's set for autofocus, so if you see it going in and out while I'm monkeying around, that's another reason why I keep my hands close, because the camera's looking on something that it can define. And I'm just going over that with my thumb to make sure that's pushed in all the way. And it is. What I wanted to make sure that there was no gap right here. And that's tight. We'll look at this end as well. So I was worried about that gap right there. So I'll take my thumb and push in on that. The other option would be if you had some channel lock pliers and come across the top of it this way, gingerly. That's the only other way you could gently control the pressure to push that in. But to get it started, I had to use bent needle nose pliers. Well, this is interesting. So far, we've got now two heat sinks, to reiterate, that have had wraparound brackets. The Thermal Grizzly I didn't care for. Too easy to bend in and out. They flex too easy. They grip okay, but it wasn't tight. These are almost too tight. It took quite a bit to pull that around. And I've got pretty good strength in my hands. But the bent needle nose pliers, that made it work. But this is a candidate for the motherboard. But the question is, how's it going to perform? How's it going to compare? And we're going to find out. Okay, assembly complete. PITA. I want to keep the Thermal Grizzly close because, like I said, to reiterate, first we test on the Supermicro dual M.2 card. But I want to see if we can put this on the motherboard and still clear I/O cards. And I want to compare that to this one based on how these brackets set up. So in the card we go, and attach. We fit right down on that escutcheon. Nice fit. Drop in the pin, and it just clears it. And that is the EK Waterblock M.2 cooler heatsink mounted. Let's look at the back side. See the way those brackets are set up on there, and the clips were pulled up from this side. So I hooked on this back side first, and then I pulled up on this front side second. And boy, that was a bear. Clearance is good on the back. We're good, we're close, but we got plenty of clearance with that component on the card. Okay, now the next step. The system. We're working with the Gigabyte TRX40 Designare motherboard, and we have two 16-lane slots and two 8-lane slots. And we're going in the primary 8-lane slot. It's already been bifurcated in the BIOS, so once we install this, we know where it's at. All we need to do is go do our test. But we're going to look at the results of the previous test before we do this. And on this motherboard, we can put in 4 M.2 NVMe drives on the motherboard. One to the CPU, number 2 to the CPU, and after we've tested on this card, we'll take that drive with that cooler and test in that position to replace that and see what kind of clearance we've got across there, if that will work on a motherboard and still have I/O cards. So in the primary 16-lane slot, we have a quad card. In the secondary 16-lane slot, we have an EGA GeForce RTX 2080 Ti because it only takes 2 slots wide, and in the second 8-lane slot, we have a 4-lane Titan Ridge Thunderbolt 3 add-in card, which means we lose 4 lanes. And that's just the way it works with dedicated resources. On motherboards, and it's important to mention this, on motherboards that have shared resources, that means something is on, something is off. With this, with dedicated resources, we can rearrange resources on a slot, but we cannot reallocate those resources on a slot to something else. That doesn't work, not on this. And if this were to be used, this heatsink, the EKWB on a motherboard, my greatest concern, again, being able to put I/O cards on top of it, but you have to remember, your primary and probably your secondary, even though it's underneath most people's GPUs, is to the CPU. Depending on your motherboard layout and configuration and chipset, any other M.2s like number 3 or possible number 4 are going to be through the chipset. So your speed for the fastest drive, if that's what we're about, and that's why we're dealing with heat, would be number 1 and number 2, CPU. Number 3, number 4, through the chipset. So if number 1 and number 2 to the CPU are the fastest, the second fastest would be on an I/O card if those I/O cards on those slots are to the CPU. Depends on your chipset. Wanted to point that out. And I say that because we had another viewer that talked about the acidity because the way it backs up to the video card, which I think is a great question, about picking up heat from the video card. Well, if your video card is next to the CPU, then your GPU would pick up heat from the CPU. So if your M.2 is on this particular card in this particular slot, are you picking up heat from the GPU when it fires up? If the fans aren't running, I'm not worried about the heat. But that's a good question. It's a fair question. As I always say, change one thing changes everything. Card is in, card is secure, and remember the EKWB M.2 NVMe Heatsink is passive cooling. Okay, next step now we need to, before we fire it up, I want to show you the results, then we'll fire it up, go through it, run the test, and look at the results again. Now this chart is labeled right now 1 through 12. And yes, we're looking at heatsink number 10. That's why I want to explain this before we get into this, so it's not like who's on first and everyone's confused. So bear with me. Number 1, the WD Black SN850 92 degrees. Number 2, I now have the numbers that I have not had in the chart for the TRX40 Designare, and that's going to be that heatsink right down there. Because remember, we have 2 M.2 NVMe drives to the CPU. Number 1, underneath this aluminum heatsink, and number 2, underneath this black anodized heatsink. And number 2 is where we've done testing, and that's the number we're looking at on this chart. So the parameters we deal with are between 92 degrees and 65 degrees. The WD Black SN850 at 92 degrees on the Supermicro dual M.2 NVMe adapter, and number 2, that same drive underneath that second heatsink on the TRX40 Designare at 65 degrees. So those are our parameters. Now, if we come on down, I agree MHQ JRH looked pretty good. It had a bracket, if I remember correctly. But number 5 and number 9 are our 2 best. Number 5 being the Sabrent Rocket 3 heat pipe, the Acidity 4 heat pipe. And the Sabrent came in at 54 degrees. The Acidity came in at 48 degrees. Then we tested the ineo twice, with and without the fan. So we had passive and active cooling, 61 and 67 degrees. And then the Thermal Grizzly, The last one we just did, 68. Okay, at 68 degrees for what the Thermal Grizzly does and the way it's designed, look at the M.2 copper, number 7, 69 degrees, 1 degree different. Now the laptop one we have to do because, as I've reiterated before, we got a laptop still to test. We're looking for a solution, so when we open up that Asus Republica Gamers Strix laptop, we'll know what we're dealing with, because when we're there, we got to be ready to work. So those are our parameters. And all I will do is add to this for the other two that we're going to be testing. Unless you guys come up with another one, I need to keep my mouth shut. But you guys ask, our goal is to deliver. And I got to tell you, I love my subscribers. I tell you, this stuff is absolutely fascinating. The most important thing we've learned about this, one, we're learning together, but two, any preconceived ideas, throw those out the window. Because, say change one thing changes everything. And we've still got a couple of thermal pads we're going to test. But we got to test these as is, as they are, to try to keep it as apples we can. And with that, the lid is off, the lid has been off. As far as the way the cooling goes front to back, some people have an open case, it stays that way all the time. And because this is laid up as if it were like a rack mount case with a top off, heat rises, so it simplifies trying to test and compare everything. But again, your results could vary depending on how you've got your system laid out, depending on what motherboards you got, depending on everything else that's going involved. But laying this out the way we have, I want to keep it simple. And let's go. Okay, card is secured, install, heatsink is secure. We'll plug it in. Let's take one more look how that looks. I don't know how well that black against black is going to look unless I can put something in there for contrast. And what I want to see contrast on as we look down through this, you get some idea of, here's the connector. I'm up against the back of the video card, and I want to point out, here's the connector on the M.2, and there's the M.2 just below the connector. And here's how far this heatsink sticks up. It's not too bad. I don't know the measurement, but I don't think the measurement is relevant until we can put it on the motherboard, and because it's not about what it is from the bottom up, but what it is from the top down. Meaning, when we put this on the motherboard, will we clear the I/O cards so there's nothing above it? So if this were used in replace of it, is it going to be better? And better would have to be better than 65 degrees. So let's see. Pull that out. Picture's always worth 1,000 words. Plugged in, turned on, energized. And the three main things we're looking at, one, we can see the video cards getting power. Number two, we can look up here and see our BIOS postcodes. And number three, we have a PC speaker up here, so we'll hear post. And once we get through the power on self-test, then we'll go to the BIOS screen, which we don't need to get into, but we'll go straight into Windows, call up our two applications, and we'll be looking at heat because we have telemetry. And number two, we'll test our speed, which is really a burst mode speed. And another test we still have to do when we get through with all this is testing the drives and see if we can figure out some actual throughput of the drives by testing something that's not in the cache. Take a file, copy it, take another file, copy it back. Okay, now this should be pretty quick and simple. Smart drive telemetry on the left, speed on the right. Hardware info, 64, sensors only. Smart drive telemetry on the WD Black SN850. And we have our current minimum, maximum, and average. We are at 32 degrees for the minimum. We'll call up Crystal Disk Mark, 1 terabyte drive, which is D drive, 1 gigabyte test file, test. And three things we will establish. One, the first thing we'll establish is PCI Express 4.0 second generation drive. The second things we've confirmed on the Supermicro dual M.2 NVMe adapter is, even though it's spec'd at PCI Express 3.0, you see the speed and the results that we achieve on that card. And the third thing we're going to achieve, as we watch the numbers when this test completes, we're going to be looking at the maximum temperature, and that will occur with the second number of writes on the megabytes. That's when we get our maximum heat. Now remember, think of this more like a burst mode test. If we really wanted to be more accurate with this, each one of these tests would need to be done or performed 3 times, because I would expect the heat to go up exponentially as we did the test, because that would be more about throughput instead of burst mode. Probably an increase, my guess, would be 10 to 15 degrees. That's why it's essential we get these temperatures down as much as we can. It's also fascinating to watch this information as this progresses with the technology, since PCI Express 5.0 is coming out, and the faster we go, the hotter we go. At 15,000 megabytes, you know that's going to be hot. The question is, how are we going to deal with it, and how are the vendors going to solve it? The test is complete. We started with a minimum of 32 degrees centigrade. We hit a maximum of 60 degrees centigrade. That's nice. And for those interested, again to reiterate, 45% now humidity, temperature of 82 degrees Fahrenheit, so you can extrapolate from that. And this is the EKWB EK-M.2 NVMe Heatsink. And on the chart, 92 degrees of the WD Black SN850 on the Supermicro dual M.2 NVMe adapter. The same drive on the motherboard, the TRX40 Designare second position heatsink, 65 degrees. And we have achieved 60 degrees. So our last heatsink that we looked at, number 12, the Thermal Grizzly, which was actually drive number 10, won't go through that again, 68 degrees. Right now what we know are heat pipes are the best. Number 5, the Sabrent 3 heat pipe. Number 9, the Acidity 4 heat pipe. And correspondingly 54 degrees and 48 degrees. So I think the thing we need to do now is let's put this on the motherboard and see if we can do any better. Going the extra mile. Pull the pin, pull the drive. So we've removed the heat sink. There's the bottom plate. There's the M.2 drive. And what we would be looking at would be this heat sink at that clearance. It comes close. I think it'll fit. Yeah, it's the same height. Let me hold that over that aluminum heat sink there. You can see it. Because there's a thermal pad under the one in my left hand. It's black. And the thermal pad under the one in my right hand is blue. And where that would sit, those look like the same to me. The problem is getting that screw in and out. That's going to be tricky. I can leave these two together. I will. Put that down as one. Well, I didn't think that was going to work, but it does. And yes, the heat sink sticks up a little bit above, but so do these others. So it looks like it's going to clear. So the big question is, can this be used as a replacement on the motherboard? Right now it looks to be that way. Let's see how well the video card goes back in. See what kind of clearance we've got. And for that particular heat sink and the particular heat sink beside it, looks like they're the same height. That is outstanding. So let's get the video card secure. Run another test. Okay, video card is secure. This time we'll leave out the dual M.2 NVMe adapter since we're testing on the motherboard. Okay, get our video plugged back in. And this time I'll go to Drive Manager just to double check where that drive is because I have a label on it. Should still be D drive. Okay, Windows. Windows flag E, this PC, and D drive WD Black SN850. Verified that. Hardware info, sensors only, smart drive telemetry activated. We are looking at the WD Black SN850, and right now we're at 40 degrees, so it's cooling down a little bit with crystal disk mark. We know we're a 1 terabyte drive, we know it's D drive, and 1 gigabyte test file. We'll do all. And the cold boot on that machine brought it in at 33 degrees, and the temperature dropped from 33 down to 40 for the time it took me to swap out the card and play with the screws, because I was concerned about that double screw, but it works. The question always comes up, do you need an M.2 NVMe heatsink? Not as big a deal on PCI Express 3, but we still recommend it. However, on PCI Express 4, it's a bigger deal. When you go from a first generation 5,000 megabytes to a second generation 7,000 megabytes, and with PCI Express 5 staring at us, that'll be 15,000 megabytes. I think we're going to see vendors come out with some smarter cooling solutions for M.2 NVMe drives. In fact, Joey, I want to thank him for this. We're going to be looking at the solution from Gigabyte on one of their drives. So he wanted us to test it. He's offered to send it. We're going to do that. Thank you, Joey. So stay tuned for that. Outstanding. Okay, first test complete. To reiterate, on the motherboard. So EKWB, on that first test, we had a minimum of 40 degrees when we started, and we got up to a maximum of 67 degrees. And if we compare that with the chart, we had on the motherboard at 65 degrees on a cold boot. So kind of a tough call. I don't think I would run out and do this to change out, but what about you guys? But I think this is absolutely fascinating. Kind of blows my mind when I see the results. But it is what it is. We've got 2 more now, thanks to Pablo. And all I can say is I want to thank you guys for watching. I appreciate your support. This is Builder Buy. My name is Gil Boyd. We're on to the next video. We're out.